Hello everyone, welcome to Chapter 5, Part 3. We're going to discuss Poisson probability distributions. Poisson distributions are defined by a set of four criteria. The random variable is the number of occurrences of an event over a specific interval. So the key to finding a Poisson distribution is when they give you a time frame. Something happens so many times per year, so many times per hour, so many times per day, so many times per decade, etc. The occurrences must be random. There must be no way to really accurately predict when and where and all that. The occurrences must be independent of each other, and the occurrences must be uniformly distributed over the interval being used. So if you're doing everything over a year, we can't know that almost everything's going to happen in January. They must be uniformly distributed. So let's do an example of how to do this. I'm going to show you how to do this in Excel. Let's go ahead and do problem 10 in section 5.5, the low birth weight problem. Go to chapter 5, problem 10, and this is in section 5.5 because I start the numbering over in each section, as I'm sure you've discovered by now. The problem says a newborn baby is considered to have a low birth weight if it weighs less than 2,500 grams. Such babies often require extra care. Dutchess County, New York has been expecting a mean of 210 cases of low birth weight each year. So once again, a certain number of cases per year is your signal that it's a Poisson probability distribution. A, find the mean number of low birth weight babies born each day. So problem A. So we know how many per year, which is 210. So 210 divided by 365 days in a year means that the probability each day is 0.575342. Now let me zoom in on this just a little bit. That probably makes it a little more comfortable for you to see. If we're doing the number, part B, find the probability that on a given day there's more than one baby born with low birth weight. And you can see the value of being able to figure out something like this. Well, in this case, we have to do our Poisson probability distribution. And either of these two will get you to the same place. They're really just dependent on versions of Excel as far as to which you use where. You may need to use, depending on your, it tells us here, this one is compatible with old versions of Excel. This one is pretty much unique to the new. I always use the old, so it's always compatible with old versions in terms of which you use, whether Poisson, dist, or just Poisson. Either will get you to the same place. So for X, we are going to enter 1 because the question says find the probability of a given day that there is more than one baby born. So 1. For the second one, we enter our mean, which is this number here, which we calculated in A. The probability, the mean number on a given day, which is also the probability. And in this case, it's cumulative because 0 or 1 would apply. So we're going to do cumulative. Now, I'm going to hit return. Let me get an answer. Now, this is actually we're not done yet. It says to find the probability that on a given day there is more than one baby born with a low birth weight. What this is telling us is the probability that more than one baby is not born on a low birth weight. We actually need to subtract this from 1 to get our correct answer, which is 0.11385 is the probability of a low birth weight baby. And this is the probability, 0.88, of a non-low birth weight baby. But you can't calculate directly to this one, so you have to do this and then subtract from 1, so look out for that. So if the question was find the probability of not having a low birth weight baby, the answer would be 0.88. All right, we'll see you in the next part of Chapter 5. Please contact me with any questions.